All right, so let's talk about a classic logistical headache. You're trying to send a high-quality video signal across, I don't know, a huge
Like
space.
a stadium or maybe a large office complex, a factory floor.
Exactly. And your standard copper cables, they just sort of, they give up after, what, 15 feet?
If you're lucky, yeah, the signal degrades, you get interference, or the screen just dies.
So today's deep dive is on this one particular solution. And I have to say, it has a truly terrible name, the NTI ST-1FODVI-L-SC.
It's a mouthful.
It is. But it has this really cool superpower. It's a DVI splitter and extender that uses multi-mode fiber optic cable. And our mission today is to unpack how this thing manages to push a 1920 by 1200 resolution signal over 3,200 feet away.
Well, that's 1,000 meters. It's a huge distance.
It's over half a mile. My first thought was, that's not a cable, that's a commute. So how are they cheating that copper limit?
Well, they're not really cheating copper so much as they're just ditching it entirely. This system uses something called the VitoPEX architecture, which is NTI's whole ecosystem. But the real magic ingredient here is the cable itself. It's a single-strand SC multi-mode fiber optic cable.
Okay, fiber optics. I get that means it uses light, but why does that solve the distance issue? Is it just about speed?
It's actually more about noise, or I should say the lack of it.
Noise.
Yeah, in those environments you mentioned, factories, industrial zones, the air is just thick with electromagnetic and radio frequency interference.
Right, from all the heavy machinery and other electronics.
Exactly. And a copper cable acts like a giant antenna, just soaking all that garbage up. But this device, it uses an 850 nanometer VCSEL optical source.
Whoa, hold on. VCSEL, can you break that down?
Yeah, it's VCSEL. It stands for Vertical Cavity Surface Emitting Laser.
Okay.
It's essentially a very specialized, very tiny laser diode. It takes the electrical video signal and converts it into pulses of light.
And since it's light, it's immune to all that RF interference.
It is completely immune.
Yeah.
You could run that fiber next to a massive power generator, and the signal stays perfectly pristine. The light just doesn't care.
That explains how they can guarantee that WUXGA resolution, the 1920 by 1200 at half mile. But you know, when you start splitting video to multiple screens, that's usually where the real configuration nightmare begins.
Oh, absolutely. That's the handshake pro.
A handshake problem, right. The computer asks the monitor, what can you display? And the splitter in the middle just breaks the conversation.
The computer's shouting into the void and gets nothing back. But if you look at the data sheet, this NTI unit has e-learning.
What does that do?
It effectively memorizes the capabilities of the display connected to it, so it can answer the computer on the monitor's behalf.
So you just plug it in and it works. No messing with drivers or configuration.
No black screens, no headaches. For the IT person installing this, that's a huge quality of life feature.
Speaking of the install, I was looking at the dimensions on these. They're tiny, like 1.5 by 2.5 inches.
It's surprising, isn't it? You expect this kind of industrial gear to be some big rack-mounted beast, but these are small enough to just zip tie behind a screen.
And the power setup caught my eye. The transmitter doesn't even need its own wall plug.
No, and that's just smart design.
Yeah.
It draws its power right from the computer's USB port. It cuts down on cable clutter. The receiver unit half a mile away does need its own AC adapter, of course.
So who's the target audience here? NTI specifically mentions digital signage.
That is the bullseye. Think of a university campus or a big shopping mall. You need to send the exact same real-time video to 4 different screens, maybe in different wings of a building.
You just run the thin fiber through the walls, hook up these little boxes, and you're live.
Exactly.
Okay, let's talk about the cost. It's listed at $525. For a cable extender, that sounds pretty steep.
I mean, if you think of it as a consumer cable, sure, but this is infrastructure. It's a laser class 1 safety compliant device. It has a 2-year warranty, US-based support. If you tried to daisy chain copper repeaters for 3,000 feet, you would spend way more and end up with a garbage signal.
So this is the difference between a temporary patch and a permanent solution.
Precisely. It turns what was a massive logistical headache into a set it and forget it kind of situation.
It really changes how you look at some of these public spaces.
Yeah.
Next time you're in an airport staring at a crystal clear flight board, you have to wonder. Realize there's probably a tiny laser blinking away inside the wall, carrying that image across a network of invisible glass strands.
Invisible infrastructure is usually the best kind of infrastructure.
Thanks for diving in with us on this one.
Anytime.
We'll catch you on the next deep dive.